Hey folks, how are you? Good, good. Thank you. Yeah, please feel free to switch on your cameras, and we can start when you guys are ready. Well, actually, let's say in about 5 or 10 minutes, right? So until then, let's just feel free to have a free-form conversation as other people are joining class, so you can talk to each other about issues or difficulties you're having, and so on. And today we're going to start coding today, okay? And in fact, I saw Tim's post yesterday. Thank you, Tim, for that post. Well, I got to say at the start that I'm not a VS Code user or an expert. The fact of the matter is I hardly use any IDEs. Most of the time, I just used a plain old text editor. But an IDE is tremendously useful. So don't use an editor. Well, strangely enough, you can use an editor during the very early stages of coding because you don't need the full power of an IDE because you're creating single files here and there. And then you get used to an IDE. But at some point, you might say, well, you know what, some things don't really need an IDE because I just know what needs to be typed and I just create these files and put them together. So sometimes you don't need that. So I haven't been creating huge projects in quite a while now. So that's the reason why I haven't used an IDE, but definitely you have every reason to get familiar with the use of an IDE. Hey, Kate, are you at Foothill right now? Is that a Foothill building behind you?
No, it's UC Santa Barbara.
Oh, it's a UCSB building. I see. Okay, cool. It does look like the PSME, the back of the PSME building. So I was confused. Great. Awesome. So that's what we're going to do today. We'll code, and in fact, what we'll do is I'll try, Tim. I'll try. What we'll do is if you can share your screen, and then not right now, okay? Let's wait for more people to join, and then if you share your screen and then get into VS Code, we'll try and figure it out together, okay? So I'm going to try and figure it out at the same time as you. I'll basically bring to bear my memory of how these things work. Eclipse, Xcode, and IDE, and VS Code. The thing is, I think I mentioned this before, you only have to get used to one IDE, usually. and then all the IDEs are very, very similar. Yes, I think I mentioned this before, may not be to 2C, but to you actually. So all the controls you need are there in every single IDE. And in fact, to make it even better, all the controls even have the same shaped icons. So those little buttons you see in the debugger, for example, step over, step into, and so on, they're actually the same shape icons too. So if you're used to it in Xcode, you know what to click. Except the problem is they're all grouped together in different places. And sometimes I think that in VS Code, some of these are hidden away unless you go into preferences and change the way the thing looks. So we'll try and figure it out. And today my plan is, unless you guys have a specific question as to how to do this in a quest, I think we walked through the quest in that orientation video. So hopefully we won't have to do the whole sequence again. And you can watch the video and see how to create a file, drag and drop, and look at the results. So today we'll just focus our attention entirely on creating a file and how to do input and output to the console, right to the console, and read from the console, read from the keyboard. When someone says, hey, you can write a program that says, what is your name? And then you're going to say that to the user. That means it has to come up on the screen, right? Or on the speaker. Well, let's not worry about the speaker right now. So it'll come up on the screen, and that person has to type in their name. That's not what we're going to do today, but I'm saying that's an example. So they type in their name, but they're going to use a keyboard. So how do you interact with the screen and the keyboard? They're not part of the CPU per se, right? The CPU has to do the CPU is the central core, the brain of the computer. That the CPU tells the rest of the computer what to do, essentially, in a manner of speaking. So the screen and the keyboard, they're not part of the CPU, they're out there. So you got to figure out some way of telling the CPU, hey, here is a string, hello world, or something like that. I need it to go to the screen. So send it to the screen. So how do you tell the CPU? And you can tell the CPU in any language, right? So Python, Java, C++, JavaScript, right? So many languages give you different ways of telling the CPU how to send something to the screen or how to read from the keyboard. So today we'll look at how C++ does it. And the syntax is a little weird, okay? Especially for people who are used to other languages like Java and Python, where, you know, printing statements and reading statements take a different form. So that's a little, but fortunately, fortunately on the positive side, this is probably the only, well, this is probably one of the very few instances where the syntax of C++ is so wildly different from other languages. So there's only 2 cases that you actually have to remember and get used to, right? After that, it'll just become straightforward, you know, and you don't even have to think about that. And then that is so simple. It shouldn't take more than 10 or 15 minutes to you know, get to grips with that. And when you're comfortable with that, what we'll do is also try and calculate simple expressions, right? Simple expressions saying, well, you know, how do I add these numbers together? How do I, you know, perform mathematical calculations, well, arithmetic calculations, right? How do you perform arithmetic calculations? And after that, if we still have time, I'm sure we'll have, you know, we'll come up with lots and lots of ideas along the way. Or maybe you guys will say, hey, you know, let's try this. And then absolutely, we will try that too. So we have, that's our plan for today. Are you guys happy with that plan? Because, right, because we're not going to do data representation anymore. But I'm thinking that at some point later on, after we cover, next week, actually. Yeah, next week we'll cover branching statements and looping, right? 2 of the most powerful constructs in any programming language, not just C++, okay? Any programming language, you want to do know how to branch, how to make a decision. Because if you can't make a decision, you're basically screwed in life, right? So, so you want to say, I see here is a value. This is, and I want to make, I want to do this if that value is an even number. I want to do that if that value is an odd number. Okay, so and so you have to make a decision and do 2 different things based on some criterion. So that's a branching statement because it branches like a fork. So we'll do that next class on Thursday. And also on Thursday, we will do looping. So looping brings a power of the computer, right? Because until we do looping is repeating something again and again. We don't really see the real power of a computer, right? No matter which language, because looping is what enables us to do iterative solutions to problems. Iterative meaning that iterative solutions are the heart of computer science, because, you know, other solutions which just go like, you know, straightforward, they're analytical solutions. Analytical meaning you get the solution and you get the answer in one shot, like that, like a math proof, right? Iterative means that you don't get the solution like that in one step. And so many people will say, you know, if I can't get a solution like that, there is no solution, right? That is usually what humans feel, right? That is the natural instinct. But the computational way of doing it, saying, no, even if you can't get the solution in one step like that, there is a way you can get the solution, because you can slowly start marching towards the solution, right? One step at a time. And this is how you do it, one step at a time. And this is how you do a single step. And once you know how to do a single step, all you have to do is repeat the same dance 5 million times, 5 trillion times, right? Now, obviously, you can't write a program with 5 trillion steps, right? Nobody has time to write 5 trillion steps, right? So what we do is try one step and say, repeat that step 5 trillion times. That we can do, yes? Okay, so that is where the power of the CPU, the computer comes in. Iterative solutions. We'll take a look at both branching and iteration next class. That basically sets us up for, you know, just knowing branching and iteration, we can solve already a great deal of interesting problems. So once we cover next week, we cover branching and looping. The week after that, in week 3, we're going to jump into something even more interesting, which is to say, let's start tackling some real interesting problems Like in fact, this morning I was thinking, well, actually, was it this morning? Yesterday I was thinking when I was in the shower, what might be an interesting, different problem to do this quarter than what we did in the previous quarters. And I thought, well, you know what we can do is try and model how a projectile will the path of a projectile as you shoot a projectile out of a let's say a turret or something like that, okay, and it goes out like that, and a gravitational field like on Earth, it's not going to go horizontal all the way like in space. It's attracted by the Earth, isn't it? So when you shoot a projectile like that, like that, it's going to go and then it's going to fall towards the Earth like that. Yes, yeah. When we throw something, it's going to fall like that arc. So I was thinking it'll actually be cool to write a program to print out the with stars, right? You shoot a projectile and it's going to say, well, here's a path of the projectile with stars, and it's going to print lots of stars like that. And we'll look at that. And I think it'll be really cool to do. And you won't believe it. The last time I did that was over 30 years ago, right? When I was a little kid and I learned programming for the first time in a language called BASIC, by the way, very, very long time ago. You can see already, how long ago that was. I learned to program, well, not learn to program, I was playing around with BASIC on a computer in a friend, in a relative's company, right? Where I was visiting him for a day, and he let me play with the computer. Because in those days, computers weren't like totally free like this, right? Not cheap. You actually had to go and get access. So I had a relative who worked in a company that had computers. So he said, come over to my office. I'll show you what a computer is. And so he sat me down at a terminal and said, here it is. There's a program, there's a language called BASIC. And he just gave me a little book, right? That book. And says, this is how you program in BASIC, and look at it. And I looked at the examples and I said, well, what's something interesting that I can do? And at that time in physics, I was learning about projectile motion, right? And I'll show you, right? I don't know how many of you are enrolled in physics or know about projectile motion. Are you familiar with basic laws of physics, like Newtonian motion and all? Yeah? Hands up if you are not. It's very simple. I will show you how to do it and I'll teach you too. But if you're reasonably familiar, that's enough. What I'll show you is how you can basically print it out in stars using what we know about Earth's gravitation. Very simple, okay? Very, very simple, like it. And simple laws of motion, okay? So we can do that, and I think that would be interesting. Unless I come, one of you or I come up with a more interesting idea for implementation, and that's what we'll do 2 weeks from now, 1 week from now, right? Not next week is just the basics, control structures. After that, we'll start looking at some real programs that use the skills that we've learned so far, okay? So now, as you can see already, that we are progressing very fast, right? Because we have a lot of material to cover and get you all prepared for CS2B, because that's where the real power of data structures is, right? So I want you all to be really solid on that. And therefore, we're going to be progressing fast. It's going to be like super duper important for you all to attend these classes. Please pass this message on to everybody else, and also be vocal, ask questions, and also participate in the forums. And also forum participation points are very important. I don't see a lot of activity there, right? You have to participate in the forums, data representation. You all had an opportunity, right? And pass this message on to all the students who are not in class today. They've got to take it upon themselves to try and find reasons to post in the forums, right? Either commenting on a post that Tim or Xiangwen have posted already, saying, hey, here's my hex name, and so on and so forth. Or saying, well, I'm trying to do this hello world quest, and I ran into this problem, or I already successfully completed that quest, and here's something interesting I found out while I was doing that, right? All of those are useful things to share, okay? And you can use these posts to also demonstrate in a manner of speaking that these are problems that you are encountering by yourself, even though the solutions for these problems already exist in past subreddits, right? Every single quest, most 99% of even interesting problems, not quest related, that have been discussed in class or other places, people in the Reddit, in past students have discussed and come up with interesting and brilliant responses, and most likely even solutions to these problems. They're all there in the Reddit, right? By not looking it up and asking a question in fresh new light, saying, well, I'm running into this problem, I don't know how to do it. right? Even though the solution is already there. Well, you don't even have to go to the Reddit, right? You can go to, the internet. You just go to Google and say, hey, how do I convert from hex to binary, right? There's going to be like a ton of videos and ton of, web pages that show you how to do that. But still, by asking that, you say, well, I'm not looking at those videos. I just want to, because I'm trying to find out myself. If you have any tips, give it to me. Because if I look at web pages online, they just tell me how to do it. No, I don't want to know how to do this particular problem. I want to know the theory behind it or understand it more clearly. So can someone help me? So those are all beautiful posts, right? Beautiful posts to have in your portfolio, right? Again, potential hiring managers don't look for people who post solutions to problems, because think about it. Most of these problems that we face, they have solutions out there. Many of these problems have solutions out there. And so if I want to hire someone, I don't want to look at someone who says, this is how you do it. How do I know if if that's their solution, or they're just paraphrasing someone else? But on the other hand, if someone actually runs into that problem and says, this is how I'm thinking about it, and I'm not able to solve it, well, that gives insight. Okay, that's why you'll find out later on when you go to interviews at companies and so on. You may actually go, you may get given a problem, and you solve the problem flawlessly on a whiteboard. Okay, and they say, here's a problem. Oh, here's a solution. And then you get like 5 or 6 problems, 5 or 6 interviewers come in and give you different problems, and you solve all of them. And at the end, you may get a call from the company saying, so I'm sorry, we're not going to move forward. And you wonder, why is that? Why is it that I didn't get the job, even though I demonstrated that I know all the concepts, right? And that's because even though you knew all the even though you showed the solutions, the hiring managers or the people that are going to work with you did not get any insight about your way of thinking. Okay, when people hire other people, they're not hiring people to get the answers, because answers can always be got. What they want is to know, is this person thinking in a way that is going to be conducive for solving company problems. Okay, so what we need to do essentially when you go to interviews is to find ways in which you can demonstrate to the interviewers how you think about the problem. Even if you already know the solution, you got to say, this is a problem, and when and put yourself in the shoes of yourself many years ago when you first encountered the problem, right? And think about what were the problems I encountered. Okay, and then you can say, well, this is a problem I encountered when I first came across this, and this is how I solved it. Okay, and is there a better way? Those are ways in which you can prove that, well, not only am I thinking right, but I'm also a very good colleague, because I'm open to better ways of doing the same thing. Okay, so we'll look at all of those issues as time progresses in this class, and like I said, it's going to be super duper important to attend class and also participate in the forums. Okay, and art and all these other, you may know, right? Any other art. Students have a portfolio by the time they go to a job interview, right? In computer science, they go with a resume, and but that's changing rapidly, right? Because with programming, people can create things in their garage at home, sitting in their pajamas on a bed, they can create stuff. So there is no reason that anyone has to hire a programmer today, right? Certainly no respectable company. I would never hire a programmer who does not have a portfolio already to demonstrate, right? So if you have a resume in which you don't have a link that says, here is where you can go to this place and see all the stuff that I've done. You can search GitHub, you can search the internet, and you'll see all the stuff that I've done come up, and you can take a look, right? So that is your portfolio. And so when an artist, when you go, right, so you have this binder, say, oh, you flip through it, you can look at all the stuff that I've done, right? Music, right? The performances. So, and computer science also, it is an art. It's not like, so you got to show what we've done and take, this is your opportunity, right? And don't wait until you've finished the entire series and say, I'll create my portfolio later when I'm really solid. Okay, no. Your portfolio has to start right now, and then it'll grow. And when it gets really big, then you can start weeding out the stuff that is early on, right? So you keep some, the last 5 projects, the greatest in projects you've done, always at the top of your resume or your portfolio, and say, that's what I've done, right? So you got to start building it up right now. It is and that is like super duper important, because this is also your chance to not just learn computer science, but to also polish and perfect your portfolio construction, because constructing your portfolio is not a trivial task. And you can ask anyone who's actually done that in other fields. Okay, constructing a portfolio, because you can't just go in with a bunch of a sheaf of papers and say, this is my portfolio, and take a look, right? Nobody's going to take a look at that. So so constructing that itself it takes a lot of time. But putting stuff together and then weeding out the stuff that is going to be distracting, not and saying, oh, all right, in my 5,000 programs that I've created in the last 7 years, right? Those 4 programs are the best to be showcased, okay? And they'll be at the top of your portfolio. Now, how would you do that if you didn't have 5,000 programs, right? It's the same thing if you're doing English, for example, and writing an essay. What does your English teacher tell you, right? If you want to write an essay and it's or creative writing, and you want to write it to, you want it to be beautiful, right? Grab the reader's attention and keep them riveted all the way from the first sentence to the last sentence, right? How do you do that? And the way to do that is not by saying, I'm going to wait until I get the perfect sentence to start. And no, you'll never get the perfect sentence, right? What do they say? They say, doesn't matter, just write whatever comes to mind, even if it's not grammatical, even if it's no use at all, just dump it. It's a brain dump, and you just put everything there, and it doesn't even have to be in sentences. You can put thoughts there and bubbles, doesn't matter at all. Okay, the important thing is to have content to mine, right? If you don't have a minefield, how are you going to mine? Right? So you got to create the minefield first by putting lots of stuff in there. Then you go in there and say, now I've, then that's the easy part. And also it's a juicy part. And lots of programmers, lots of writers miss out on the juicy part, right? Because for many people, writing does take a little bit of effort. But pruning the writing, editing is actually a fun part. Okay, I don't know. I don't know if you guys are enrolled in creative writing, you probably have experienced this. But editing your document is actually a fun part. Okay, you would actually enjoy that. You look forward to that because you know that you have a lot of stuff already. All you need to do is now polish it up, right? So when you have something and you just need to know, I have it. I've got my back. I don't, now all I need to do is make that look better. I can go in there and remove stuff that are not, that's not so cool. That is fantastic, because everything you remove will start making the portfolio better and better and make it shine, right? You're basically taking a diamond and rubbing off parts of the diamond, right? Getting rid of the diamond so that it shines better. That's why you cut it, right? Because a diamond could be this big, but like that as a stone may not be as attractive. But you take the diamond and say, well, I'm going to cut it and throw away bits of it, right? So you've actually lost a bit of a diamond, but the remaining part is really shining, and everybody wants that. So like that, create your raw diamond first, which is your essay or everything that you want to write or create or program, right? It's got a lot of stuff in it, but then you want to say, well, I've got this now. Now I've got the raw material to go with my chisel and hammer, and I go and chip things off so that I got the nugget that is really valuable and everybody would love. Okay, so that's what you want to be creating. Start right now, and it's never too late, but this would be a good time for you to start, because you're starting to program as of today, right? And I'm actually looking forward to diving into VS Code with Tim, because it's been a long time. And obviously, I sympathize with Tim's point, saying, well, he probably saw Virginia's video from several quarters ago, because she did a walkthrough of VS Code and how to set it up. At least Virginia, maybe a few more students and obviously VS Code is a live, active system development. People are developing and maintaining it right now. Right, as we speak, new features are being released into VS Code, so it's changing on a day-to-day basis. It's not like in those days where software is updated every year or things like that. Software is updated every second, and even as we speak, go to Google or Bing and type in a search query. Two search queries. It's very likely, actually, it's unlikely. It's unlikely, but it's possible. It's very possible that between two search queries, the core engine had changed. Right, there was a new release rolled out, and you don't know it. But the same query typed like 10 seconds ago would have got you different results, right? And this doesn't happen, but sometimes in corner cases it happens when you can catch a major release from a big company that is not, because they're rolling it out every single day. Any company you go, any product that is public facing, they have release schedule, right? They have release managers, they have release schedules, and they have meetings and say, what are you going to release today? What are you going to release today, right? So every single day they have a timetable and a release and schedule saying, all right, today we'll release that feature. Today we'll release that feature, right? At 7 p.m. today, that feature gets released. And these decisions are not made, like that. They'll say, well, what is the best time to make that release, right? It's going to be 7 p.m. because 7 p.m. Is when the least users in China or Africa or some distant part of the world is midnight, right? And they're least likely to be using this product. Okay, so and since this feature is going to affect them most, let's try at that time, so that if there's an issue, then we won't be impacted as much. We'll find out really quickly without affecting a lot of users. You see, so a whole lot of decisions go into when products are released, but they all release every single day, every single moment, actually. What was I going with that? Yeah, so things are changing every single day, and VS Code would have changed. So I'm not at all surprised that that Tim ran into issues trying to look at the old videos. But that doesn't mean you shouldn't post videos like Virginia did. If you do want to create a video of how to install VS Code and get question code, or start creating question code using VS Code, it will actually be a welcome video, because it will be appreciated by not just our students today, like the rest of you. It will be appreciated for at least a few more quarters, right? Until some, future quarter, when someone says, hey, you know what, I was trying to learn VS Code, and I look at, Sakshi's video from spring 2022, and it didn't work, just like Tim said of Virginia's video, right? And it might be a post like 15, 5 or 10 quarters from now, and that's perfectly fine, right? Because at the time the video was published, it was perfectly useful for all the students. So that's where we're going to go today. And I think if you have any other ideas for what to do, feel free to chime in. Otherwise, what we'll do is essentially, when Tim picks up the screen, the first thing we'll do is try and get ourselves going with VS Code and saying, let's create a hello world program, just to make sure that we're able to start a program and write simple programs, and then start looking a bit more in detail into how to do input, output, and expressions. Okay, so all right, now hey Tim, you should feel free to also talk and say and speak about what it is that is challenging and what problems you ran into, because since I'm not entirely sure what the thing is, once you run into a problem, we can try and address the problem together, because if you say, for example, I can't locate this file, or I don't know how to get it to compile, and so on, then I can say, all right, let's try this, and so on. So is that okay with everybody? Yeah. Fantastic. Okay. Well, only Kate is nodding her head. It's okay. The rest of you at least have to raise your hand or say yes. Yeah. All right. Okay. Great. Excellent. Thank you. All right. Now I've got to reduce my screen so that I can get more of you on screen, which means I have to change my glasses. Okay. All right. Now I only have half the screen, so I can get. Hey Nate, you should switch on your camera so we can have your lights in the background. Really cool. All right, so I can read the small font now. Okay, see this.
Could lower the resolution, try and make it a little
larger.
Yeah.
One sec, okay. Just one sec. The other thing I realized is that the speaker on this Mac, the speakers on this Mac are bust. This Mac is like 10 years old, and still it's perfect. Brand new. The only thing that's wrong, I think, are the speakers, and they're probably torn or something inside. But I'm still using it, right? In fact, the entire questing system and everything a lot of stuff was developed on this Mac. So it doesn't. All right, let's see. Now, can someone say something? I want to make sure that it's connected.
Yeah. You hear me now?
Is it working well? Fantastic. Yeah. Great. Previously, I wasn't using this. I was just, patching out the audio to Alexa. But I think there's a lag between
you know, between the transmission. As soon as I say her name. Okay, so there was a lag between. Okay, all right. So there was a lag, and then because of Bluetooth, I think. Alexa, stop. Okay, so there was a lag, so that, you know, when I'm looking at the screen and you guys are talking, I can see your lips moving, and then like a few seconds later, not a few seconds, few milliseconds later, the voice comes out there, and it's kind of jarring. So this is much better. Thanks. All right, so I can read the screen and look at most of you. I think it's most of you. Let me make sure. Yeah, that's most of you. All right. Okay. So let's see if we want to create. Let's see if we can try and create a simple file, which is, let's try and create a hello world program. It's just going to print hello world like we did in the orientation video. We'll write a program that's just going to say hello world to the console. And then we'll take that, and I'll take that program and explain how the program works, and the different parts of the program, like hash include and all those things, using namespace, things that you probably already have questions about, saying, you know, when you type the program in, you're going to have to type all these things on top and say, hey, what is this? Why do I have to type this hash include? So I'll go into those if necessary. Okay, it's all very simple. So all right, so let's see. Let's say we want to create a new. Let's create a brand new folder first on the desktop, so that, you know, eventually you'll know that it's all in there. It's self-contained. You can delete it. Okay, so let's create a brand new folder on the desktop and say, you know, CS2A. What is today's date? 12 April. Yeah. So just say CS2A 12. Yeah, cool. All right. So yeah, and is this a Mac or a Windows, Tim?
This one is Windows 11. I think.
Windows machine. Okay. All right. Cool. And yeah, I can also show you, if it's a Windows machine, how to go into the terminal and do these things.
Sure.
Although, you know, I might have to. I don't know if I still remember, but we'll try. All right. So now create a. Yeah, click the File menu. Open workspace. Open folder. Add folder. Okay, workspace. Delete. Let's create a new file. Let's create a new file. I think, yeah. And how do you rename this file? Just double click on untitled one. Oh, rename it. You can't rename it. Now we want to get the package.
Save as first.
No, there should be a pack. There should be something called a package explorer, which shows you the folder and the content somewhere. So there you go. Yeah. If you single click on it, I think it'll let you rename it. Single click. No, single click and wait. No.
No.
How do you rename that file? By the way, I shouldn't be the only one. If someone here
I think
in
you have to. Oh, sorry. I think you have to save it first.
That's what I was thinking.
Oh, you have to save it. Okay. All right. Yeah. Save it. Thank you, Michael. Michael or Mike?
Michael's fine.
All right. Just save it as hello.cpp. In fact, save it as hello_world.cpp. Okay. So and all lowercase, because that's what the questing system needs. But although, right. So hello_world.cpp. All right. Now this is the file. So let's type in a program there. So for now, since we're trying to figure out the VS Code details, I'm not going to go into the details, but I'm just going to call out the code. You can type it in, and then once we have the basic code there, we're going to try and compile it and all, and find out how we do this in VS Code. Then I'll go into the details and explain these things. So type in hash include space ;sign. This is angle bracket. Okay, less than is angle bracket. Sometime I'd say angle bracket. Okay, angle bracket, and inside you say IO stream. All right, and then go to the end, and then blank line there. And you'll notice that when we're typing like this, and I'm calling out the code, I'll say blank line and space and things like that. It is just my style, okay? My personal style. You don't have to follow the style. You can follow your own style when you're typing. But I suggest that this is a good style, because this is not my style, okay? This is a style that I've picked up by looking at lots and lots of people's code on the internet, working with friends. Okay, so it's a good style because it's easy to remember and the programs look pretty this way, you know. And also when you write programs, one of the things that CS2A students I feel are not all familiar with is just to treat the program like an English essay. Now, how many of you have written essays in any language, right? English, whatever the language is, right? So you have written essays. So what does the teacher say? When you have different concepts in your essay, don't write it all in one monolithic block, okay? One big paragraph. People are going to say, I'm not going to read it, give it back to you, yes? Okay, so they say, they have different things to say, just separate them out into paragraphs so that it's easier to read. And people also have, you know, puts them in the right frame of mind when they read different parts of your program. So here, so in your program also, bring the same thing to bear. So when you have different parts of the program that are doing different things, separate them out, saying, okay, that's the part that deals with declarations of variables. This is a part that does with, you know, compiler directives. And even inside your program, you may have not trivial logic, right? You may have something that you need to do, which consists of 5 different steps. And the 5 steps, maybe, you know, the first step might involve a number of sub-steps. So you may have 10 statements here, that's the first step, another 10 statements for the second step, and so on. Now, in those cases, it is actually super duper useful. And in fact, professionals expect this of us to say that I'm going to have 5 steps, and then they're going to be a blank line because that's a paragraph. So each chunk of logic, right? So a coherent logical unit in your program should be separated out, just like in English, right? A coherent thought chunk that's separated by blank lines. So we use blank lines. That's what I'm going to do. So you can either do what I do or come up with your own style. That's fine. Okay. So here you're going to say using space, namespace, a space. There's too many spaces here. Okay. Space std, and then semicolon. Okay. And then a couple of blank lines after that. And then here, oh, actually just one blank line. One blank line. Sorry. Right. I meant to say a couple of returns, enters. All right, so here you're going to say int space main, open close parentheses. When I say open close, I usually mean just open close parentheses. Okay, yeah, and then space, and then curly brace, or left curly brace. I think it's shift. Yeah, there you go. Right, and hit enter. Okay, so and then at the bottom, before the closing curly brace, the last statement should be return space 0 semicolon. Okay, now that is your basic template. Okay, that is a functional C++ program. It doesn't do anything at all. Okay, absolutely nothing at all, but it will compile and run. Okay, it does nothing, but it compiles and runs. So one other thing that I tend to do is that when I have a function and then the parameter list, I don't have a space between the function name and the open close there, because the parameter list and the functions people usually keep together. So that's just my style. So you can get rid of the space after main, all right? The word main, so that yeah. So it's the main open close. That whole chunk looks like a word, but because it ends in open close, we know that is a function. Okay, so that is the convention that many people follow. All right. So in here you're going to say cout. Double less than, and the double less than is also called a left shift operator. Okay, it is, and you'll know what it is later on. In data representation, when we talked about data representation in last class, you know, right? We have a bit pattern. What do you do when you multiply the bit pattern by 2? What happens? All the bits shift left by one. Yes. Every time you multiply a bit pattern by 2, all the bits shift left by 1. Yes. Yes or no? Do you remember that? Right? So 0, 1, 0, that's 2, isn't it? Right? But what is 4? 1, 0, 0. So what happened? The 0, 1, 0, the whole thing shifted to the left. The 1 shifted to the left, and a 0 got shifted in, right? So that's left shifting, and it is a very fast, super duper efficient operation at the level of the CPU. Because one instruction at the level of the CPU that says, bam, do the shift, and it's so fast. And you can do multiplication and division using shifts like this. Right? Well, not all multiplication and division, but basically by the base, as we talked about before, right? So that is the left shift operator. Some, I think some instructors call it the insertion operator. Okay. Now, I never got used to calling it the insertion operator, mainly because I don't know, maybe too many syllables in there, right? Or I didn't learn C++ using that terminology, so I never got used to it. So I call it left shift. Okay, so that's all right. So put a space before the left shift. Yeah, it looks nicer that way. All right. Now on the right hand side, again a space, and then open double quote. No, double quote. Yeah. Oh, what happened? Yeah. Yeah. Thank you. Right. And then inside there, you say hello world. Yeah, hello world. And then let's also put a new line character at the end, /n. No, it's a backslash n. Yeah. All right. And get rid of the space before the new line. And it's actually not, this is not stylistic. Okay. So this particular space that we're getting rid of is not stylistic. It is actually efficiency. Why is it? Right. In fact, it is efficiency that is hardly going to be noticeable, right? And most probably even the compiler may be intelligent enough to get rid of the space itself. But that space, getting rid of the space in the code is actually an efficiency issue, because that space is not going to be visible, right? When it prints out, there's going to be a space and then a new line after that. So that space is not going to be visible. So why do something that is going to be totally useless? That is one of the cornerstones of computer science, is to say, and that is what my CS2C students are trying to figure out with the first lab, the first quest right now. Is the first quest in CS2C is about how you take a big problem and get rid of things that are not necessary so that you come up with the solution, right? That is one of the ways of finding solutions, right? The solution isn't there. All you need to do is get rid of things. Search problems, right? Because searching is a big field in computer science. How do you search? How do you search these massive data sets? And one way of searching is actually linear search. Go one after another and trade. And so the other way of searching is to basically get rid of things that you don't need to look at. So that will say you can reduce the amount of search space. Reduce the amount of space you have to search. So that is, and there's lots of techniques by which you can be clever about getting rid of things that you don't need to look at. And sometimes you learn. In fact, even in CS2A, in week 6, you learn how, if you're given a huge data set and asked to look for something in there, you can learn clever ways of saying, well, I don't have to look through the whole thing. In fact, I know for sure that the second half of this data set does not have my answer. So I'm not even going to look in there. I'm going to only look in the first half, right? And that might save you like a ton of time. And so one of the key things that we'll pick up in computer science is how to be clever in identifying the work that we don't need to do, just like in real life, right? Most people spend a lot of time doing stuff that is totally unnecessary. It's not going to help them at all. They think it's going to help them. They think it's going to give them happiness, but it's not, right? So identifying what is it that we don't need to do, it's ultimately not going to pay off. That is essential. And that is, the first place we've encountered that. Putting a space there, or even putting the space in the program, is actually useless because nobody's ever going to see it, right? And it's, it's not of any value at all. So that's why we get rid of it, okay? And then every statement in C++ needs to be terminated with a semicolon, all right? And then the return 0, what I do is the return 0, I separate it out because it's the final paragraph saying that's the closure, right? That's the closing. All right. So now that is a complete program. It should compile and run. However, there's a problem already. We can see that there is a red underline. Yeah. If you mouse over, okay, what include errors? Include path. Squiggles are disabled for this translation unit. Okay. All right. So how do you set the include path? So if nobody here knows how to set the include path in the settings of VS Code, we can go to the settings and figure it out. If you just go to Google and say how to set the include path in VS Code, I'm pretty sure the very first hit will tell you how to do that. Does anybody know how to do set the include path in VS Code? Or Tim can basically open up a Chrome window, incognito Chrome window, a private browser window, and in that window, yeah, let's type. This is private, isn't it? Tim? Yeah, all right, cool. So type in how to set, setting include path in, how to set include path in VS Code. In fact, put VS Code as the first word because the order, you'll get a better, I think you'll get a better, I put VS Code there. No, one word VS Code, one word VS Code. Someone had a question.
Yeah, that might help. Tim, do you have the package for C++ and C downloaded on your VS Code?
So yeah, that was where because I could have followed with that or started with that.
Oh, I
don't-
see. You,
This is
you
just a
haven't
fresh
installed
install
the
of VS Code here, so might be
Yeah.
lag.
I see.
So if you click on the, what is it called? The little squares extensions on the left under the debug button. Yeah. And then you type in C++ or yeah, this one, yeah. You install that. Oh, you already have that?
Oh, you installed it already, huh? Hang on, but let's take a look at this quickly. So it is there. All right, that looks all right. And this is the Microsoft C++ compiler, not MinGW, I think. So that's fine.
That's correct.
Okay, so it's got tutorials per compiler and platform, Microsoft, okay, and GCC. Oh, all right, so it actually click. It looks like a link. Microsoft C++ compiler and MSBC on Windows. What's the next one? No, click on the next one, GCC. I think. Yeah, click that. Yeah, okay. Yeah, download that. Download that. Click download. Yeah, Windows, download that. And there were further instructions too on that VS Code. So let's, while it's downloading, let's read the remaining instructions. Yeah, click download, and then let's read the remaining. Yeah, thanks for VS Code. No, on the previous page in VS. Oh, go to your VS Code. I think. Oh,
Yeah.
Was it? Yeah, it had some instructions. Oh no, it doesn't. C++. Extension overview. Okay, well, let's install it. The other page you had, I think the other page had more information. And it looks like Shadi is probably familiar with the system, so she can help us.
Did you want it to actually go into your code just to make sure you didn't type in anything wrong? Because I'm doing the same thing that you are and I'm not getting an error.
Right.
So include IO stream.
So when you mouse over it, it says it cannot open the source file. So like, that's the second part. No, never mind.
Just the settings. I'm pretty sure it's a setting somewhere. If you go to that web page and it says how to create your very first project, that has all the information. I'm pretty sure, right? That web page you had before.
Right here.
Yeah. Okay. Visual Studio. Yeah. Code in action. No, is that where it is? No, that's all. Code completion. All right. Let's install it. Install it in VS Code, and then what you downloaded, install it, and hopefully that will basically set all the default values. Is it done with the install? Yeah, let's do that. Click that and run it.
Yeah. So that.
Yeah.
looks
You
like
can
the installer for Visual Studio Code.
you can quit VS Code for now while it does the install, and then we can restart it. This file will still be there because you saved it, right?
Yeah.
Okay. So you can quit VS Code and install this. Now, if this whole thing doesn't work, and then Shadi and I are not able to figure it out, I want to. We will still code, right? We'll just go to I'll show you how we can for today, we can just go to an online environment like LeetCode, or actually I found out that LeetCode also has this nice little area where you can code and run the code also. Last quarter, we used to use, I think, online GDB or coding rooms. There's so many environments online, free places where you can go to code, right? So, but this quarter we can try, LeetCode itself. I haven't tried it, but yeah, I mean, I was curious, so we can find out. But if VS Code works, that's even better. Hey, it's gone. Wow. Okay, so it's gone now, is it? The red underline is gone, right?
Looks like it.
Yeah, it seems like it.
Oh, there it is.
Oh, it's still there. Okay.
It says view problem right at the bottom left corner. So probably that would open.
Yeah. Thank you, Jaden. And there was
Please,
detected.
please update your include path.
Okay. All right. So let's say in your Google, in your search window, just say how to update. That's what we typed, is it? How to update include path. How to? Yeah, there you go. And make include path one word. One word.
Professor?
Yeah.
Just one recommendation. If the folder, if the file you're creating is on the desktop, depending on what operating system you're using, it changes the file path. It does the same thing for Mac when you're installing Python, like the ZBash shell. It's like they don't install it with Python original one that was sent with the Mac. It would send it to a different one. So if you can try saving the file wherever your vStudio program is installed in, like whatever the local area where it is installed, where it doesn't have to look for it from the desktop.
Oh, I see. But that means all the projects are created inside the place where VS Code itself is installed. Is that
the project? Yes. When it starts running the project, it will use it. It would use the file from bin. But when you save it, it completely cuts it off. If you save it on the desktop, it completely cuts it off. So when it tries to look it up, it can't find it. So it's just a suggestion. If you try putting it with the same directory, it might be able to pick it up. It's like you can rule out that issue if we do that. Try it.
I see. All right. So let's keep that in mind.
Suggestion.
Yes. No. It's a very valuable suggestion. I'll keep that in mind.
Okay.
But let's click on configure. I saw the link. Yeah. How to configure include path. Yeah. Click that. Oh, there it is. Code sample. Yeah. Okay. Cool. How to configure include path. Okay. Everybody seems to be having that problem. All right. So CPP properties. Oh, it's stored in a JSON file. Okay. So where do you put the JSON file? Oh, that's what he's asked. Okay. I want to know where to put the JSON file. Okay. So I'm pretty sure there's an answer somewhere. Okay. All right. There you go. Configure include path for better results. All right. Where are the include paths defined? In the include path setting in a file called CPP JSON. All right. So in the VS Code directory in the open folder. Okay. So, oh, I see. Operations.
Sorry to interrupt, but I sent you guys a link in the chat that might
Hey,
help
cool.
because it seems like we did download the MingW W64 thing because it was the link for GCC. It seems like there's a last step to have that working, and that is to change your settings, your Windows settings. That is what I'm understanding from the instructions from in that link. So you might want to follow step 5, which is adding it to your bin folder and like going to your Windows search bar and typing settings and all of that.
I see. So add it to install Visual Code. I clicked on the link that Shadi sent. By the way, you don't have to apologize for interrupting, okay? Because we're all talking at the same time. You know, you're not gonna, if you're in a group conversation, you're not gonna start everything you say with, I'm sorry to interrupt. So, all right. So install, all right. And then, get the latest, okay, installation process. All right. Take care to run each start menu item and when you install the actual. All right, maybe that command needs to be run. Add the path to your MinGW bin folder. Oh, to the window. All right, so that needs to be added so that it will run the compiler to the path variable in the Windows search bar. Type settings to open your Windows settings. Okay. Okay, let's do that really quickly. Just add this. Is that where it's installed? So open up your Windows Explorer and go to command.com. Run a command shell in your Windows, and let's make sure that we actually have that file there. MinGW is installed or not, right? So we need to see that in this directory, c:/min64/mingw64/bin. That directory actually exists. Let's make sure it's there, and then we'll add that to the path. That'll just make sure that VS Code runs, but still we haven't told it where the include path. Where to find the include path? That's probably further down on the same page. So let me see. Create hello world. Well, that's what they're doing too. Make your project, CD projects, make your hello world, CD hello world, code dot. Okay, that's fine. And as you go through the 3 files. Oh yes, this is exactly what Nate said. All right. Nate, this is exactly what you said. It said, we just saved the folder. We just saved the file in a folder that has nothing in it. It says if you want to create what it's saying is if you want to create a project, that project needs to have your source file, but also these other things that are associated with VS Code. So I think that's the part that we don't have. So we will put that in there. So let's do this. We have to say code dot. Okay. All right, let's do it properly. Okay, now I think I understand how this needs to be done. Thank you, Shadi, for sharing that thing there. So let's first go to your command window. Go to your command window. Where's my Zoom? Oh, here it is. Go to your yeah. Can you open a command window somewhere? Let's find out if you actually have code. We need to have great. Yeah, actually, just type. Just type G++ or C++ and hit enter. I want to see if bad command. Okay, no, good. Min GW and hit enter. Okay, all right, cool. Now let's go to that directory on that page. CD to /CD, CD space /. What was the directory name? Does anyone remember? It was on that web page. Yeah, CD /msys64, msys64, and hit enter. Let's see if that directory actually exists.
Is it M what?
Yeah, msys64.
SYS.
SYS.
Oh, sorry.
64. Oh, how come it didn't install MinGW there? Did we do a default installation of MinGW? Did we install MinGW?
I did not go to the MinGW website to install it on this machine.
Oh, I see. Okay, let's install that too, right? Maybe I thought the VS Code extension automatically installed it, but obviously it didn't. So let's install MinGW. Seems like it's not there. Yeah, click that, the second one, and let's install that. Install the we install the extensions, and now we need to install this too. All right. So further down, I think there will be installation instructions. For Windows.
There's a website that says you can provide the MinGW64, which provides up-to-date builds of GCC W60 MinGW64 and helpful C++ tools and libraries. Do you want me to give you that one instead? The link to that one?
Yes. Thank you. Yeah.
So it's in the chat.
Got it. Yeah. So it's msys2.org. If you go to msys2.org, we'll find some kind of installer there, I'm pretty sure. Yeah, and yeah, installation, yeah, click that. Excellent, yeah, all right. So yeah, and then all we need to do now is, if it's done, it's done, it's downloaded already, I think. So yeah, click that. I'm pretty sure it's going to download now. It's just downloaded the shell of the installer. Now, when you click that and run it, it's going to download the actual package, because you couldn't possibly have downloaded the entire compiler in like 0 seconds. And by the way, because we want to get to coding also, if this takes more than 5 minutes more, what we'll do is we'll just go to start coding in LeetCode or something, and then one of us can figure out how to do this. If nobody does it, I will do it, right? And then share the video or in Reddit and YouTube or something like that. Okay. So, but hopefully this will fix it, because I am curious to see how to get this going. Yeah.
Is this the compiler? Oh,
Yeah, it is a
image.
compiler, Chengwen. Yeah, it is the compiler. I think it wasn't there before, probably.
So the C++ package, it does not include the compiler. We have to
No, it wasn't
download
a
it.
C++ package. What he had before was just VS Code. That is the IDE.
But I thought
it's just-
we already downloaded C++, the.
That's what I thought. That's what I thought, because it said Microsoft C++ was installed, right?
Yeah.
Yeah, but rather than try and figure out where it's installed and things like that, because my experience with the Microsoft compiler, well, actually most of these compilers, even the Apple ones, that things are scattered all over the place, and it takes a long time to figure out where things are. And I just go with the default settings most of the time.
Professor?
Yeah.
Just it might be another recommendation, but Windows 11 is not really up and running. Like they're still working on bugs.
Oh, really?
If anyone has an option to check it with Windows 10 or Windows 8, if anyone has one.
Is this Windows 10 or 11, Tim?
This computer is 11. I think I could probably figure out a way to get Windows 10 back on here.
No, but let's see. I see the point. The point that Nate is trying to make. If this doesn't work, what we'll do is let's not go to Windows 10. If this doesn't work, let's just go to coding rooms or one of those online environments and start coding. Because IDEs are strictly not necessary until a couple of weeks from now, when we start coding more important, bigger projects. So I don't want it to take too much time. Now type. What is this? Well, how do you get a dollar prompt now? You got a different shell.
Bash.
This is what
You got
comes
a
up
bash.
after the installation completes.
Wow. Okay. Now type pwd and hit enter. Pwd. Enter. Wow. It actually put it. All right. Now type cd slash space space. No, cd space. Yeah. Cd space. Forward slash. What was it? What was the directory name? What was the directory name we had before? msys64. 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 Still no directory? Yes, I think what Nate said was probably right. It's doing things differently in Windows 11.
Yeah.
Maybe. Yeah.
That might
Maybe
have
it's
been why
doing
I was
things.
having an issue trying to install it earlier.
I see. All right. So let's not belabor this anymore and waste time. I will try and figure this out, or one of you can figure it out. Maybe Shadi probably already knows, or Nate can figure it out. What would be really helpful is if you can post a set of instructions, and also, if possible, capture the screen when you're trying to install it and post a short video. And I'll share that video on our channel, Nonlinear Media channel, and we can share the link. That'll be useful to everyone. And if nobody does that, I will do that in after a little while. What we'll do now is let's just go to open another tab, and we'll start coding right away. Okay. What time is it now? I don't want to waste. Yeah, it's already 9 o'clock, right? Let's not waste any more time. So now go to leetcode.com, LeetCode, because I saw this and I never tried it, and I want to try it, and this would be a great. Just go to LeetCode. Yeah. All right, cool. Now I think here, you don't have to create an account. I think I think it just lets you code right there. Further down the page, you'll see. Click get started. Further down, you actually get a window where you can start coding. C++. Do you have is there a C++ link there? All right. Let's go to another site, because I shouldn't have gone to LeetCode because I've never tried it. I wanted to try it, and I was trying. Let me double dip and try it during class. Okay, just go to cpp.sh, right? Because we've used it tons of times. Yeah. All right. So here, this is a place where you can actually type your program, get it to run, and do everything we need to do to understand a program. All right. Because if you hit the run button now, you'll see the output of that program right there. Hit the run button, and there you go. What is your name? Actually, it does a non-trivial program. It actually asks you for your name. So you can get. You type your name, and I'll explain what's going on. Type your name, and it'll say, hello, Tim. I think it should say hello, Tim, right? There you go. Hello, Tim. All right. So here's what this program has done. So if you guys are happy with it, what I will do is basically explain what the components of this program and what's going on, right? We're going to defer this issue with VS Code, right? It's my brave attempt to basically try and decipher this during class failed. So we'll do that later, but I'll explain this program. Is everybody okay to start looking at the code and trying to understand what's going on? Yeah, all right, great. Okay, thanks. So this is a program which is very similar to what Tim did before, except it's got one more line, okay? And it's not laid out properly. So let's, so here's what I tend to do. Put a blank line after line 7, because the first line 7 is what is called a declaration. A declaration says, in my program, I'm going to be using various things, right? And the things that I'm going to use are of different types. I'm going to use a variable called name, and that name is of a string type. Okay, that's what you said there. So my name is a string, and maybe you're going to use an integer too, right? So you say I'm going to use a variable called j, x, or something like that, and my j is an integer. So you say int space j, right? So you may have many different types, and that's where all the declarations go. The declaration part of your program comes at the beginning of a function that says, in my function, I'm going to be using a number of variables. Right? These variables can take different values, and this is where I'm going to declare those variables. So the declaration part, and so we put the declarations there, and then we have a blank line saying, okay, that's the declarations paragraph. And following that, we have, you know, the logic section, which is where you're going to do stuff with the variables that you've got. Okay, and this program is not actually written in the best possible way because it's been missing the return statement. So let's go to the end and add the return statement just to be, you know, pedantic about it. This is also clean, right? Because if we don't have at the very end one more blank line there and say return, one more blank line and say return 0. Yeah, you see, Tim indented with 4 spaces, which is what we're used to. But you know, this template program only has 2 spaces for indentation, which, you know, some people use. I tend to prefer 4 these days. So, all right, so good. So return 0. Now, the first line, line number 9, is going to print something to the console. I will come back to this, okay? Because I want to explain hash include and things first, okay? So the first line, line 9 says, cout essentially says, send this to the console. C stands for console, and out says output, right? Cout says, cout is an object. You will create objects later on. So, and all of this will make a whole lot of sense. Now, one of the things I want to tell you right away is that as we're coding and as we're talking about things, there will be things that we don't understand yet, like, you know, cout and objects and so on. In C++, as with any other programming language, I guess, you just have to say, all right, this is what it does, and we're going to go on. In just a couple of weeks, you'll understand what it is, because we haven't talked about objects yet, but we're going to talk about objects later on. And when we talk about objects, you'll know, oh, that's what cout is. What cout is basically a special data type that has already been created for you by the creators of the C++ language. Now, the important thing to remember, and a lot of people don't know this, they think that cout is part of C++, right? No, cout is an object that has been created by a programmer just like us. Someone like you or me sat down with the compiler that has already been created. The compiler is C++. The compiler does not have any idea of what cout is and things like that, okay? So the compiler basically says, if you have something in English, I'll just translate that into binary for the computer, right? But in order to do stuff, we need more things than just basic things like, you know, branching and looping and things like that. We need to know how to talk to the screen. We need to know how to, you know, talk to the keyboard. So what the original designers of C++ did was, here is the basic core C++, but in order to use that, you need a whole bunch of things, packages, right? So here is a package that needs to be able to talk to the screen. Here's another package that needs to be able to talk to the keyboard. Now, all of these need to be, they're not part of C++, but you need those in order to be able to do anything non-trivial with C++. So rather than you waste your time as a professional programmer, every time you want to create something, rather than waste your time creating these things, which is going to be the same, the standard stuff that everybody's going to use, we'll create it for you, okay? So when you install the compiler, you don't get only the compiler. You also get all these packages that programmers have developed, like us, right? Programmers have developed and made available to the C++ community, such that these, you know, creators of C++, Min G++ and Microsoft C++ and so on and so forth. So what they've done is saying, all right, when we ship our compiler, we're going to ship with it these packages also. So you get, with the basic compiler, you also get things like cout and things like that that have been already developed. Now, if they had not been developed for us, we would have to create cout and cin and all these objects before we can do anything significant, right? So the important thing to remember is that cout and cin and all these things that we're going to use, they're not really part of C++. They're just objects that have been created by someone else. They could have been called something else. You can create an object like cout, which is something completely, has a completely different name. In fact, I'll show you how to do that. Yeah, in fact, I can show you in a few minutes, okay? So that is essentially what this program does. The first line says, print it out. That is a prompt, okay? Print it out on the screen. The second line says, get a line from, it's a function call again. That function, get line, written by a programmer, okay? And it's in the library. It's in the library. Where are these programs, right? So where are these things? They are all in the library, and the compiler has been told where to find these little functions like get line, objects like cout, all of those are in there. And the compiler is being told, here's where you go to find out more details. And I'll put all of the details about these things that you're going to use in a special file called iostream.h. Okay, there is a special file called iostream.h that lives in the compiler, in your computer somewhere. Okay, I can show you how to find it later on. It's in there, and in that file there are thousands of lines of code, okay, which we don't even see. And in those thousands of lines, the programmers have defined the object called cout and how to use cout, and all those things are in there. Now, rather than us typing it in, all we have to do in our program is type one line right at the top of our code saying hash include iostream. Okay, that line at the top that says hash include iostream is essentially a signal to the compiler. In fact, it's not the compiler. It is something that goes before the compiler called a pre-compiler, pre-processor. It's called a preprocessor, right? C preprocessor, CPP, right? So that program, before it takes this, what is it, 15 line, 14 line program and sends it to the compiler. Before it sends it to the compiler, the preprocessor is going to take that program and it'll look at that program and says, well, you know what? There's something called hash include a file. Between angle brackets is the name of a file. Okay, so iostream is the name of a file that lives somewhere. Okay, and it lives in a place called include path. It's not in your directory, it's in there. And the compiler needs to look in that include path. That's why it said before it couldn't find it, right? Because we didn't set it and all. It lives somewhere. So it says the compiler will say, this guy is going to say, this program has a hash include. So what that means is that I'm going to fetch the entire content of that iostream file, which could be thousands of lines. Okay, and I'm going to stick it right here in this program. Okay, it'll remove the hash include line, and in place of the hash include line, it's going to stick in 1,000 or many thousands of lines, which the original designers of C++ wrote for us. So there is a file in there that has this in the definition of these objects. That's all in there, and we don't have to type in the definitions of these things, and we get that for free. So that one line there, hash include iostream, just gives us a whole bunch of things for free right there. And that's what the line means. Yes, are we on the same page so far, Rico? Okay, so that's what, and likewise, we're going to be using an object called a string. A string is basically a series of characters, and we saw in data representation, ASCII characters, right? So a string is basically a sequence of ASCII characters. Now, however, in C++, they say, we decided that, just a string of ASCII characters, yeah, it's really cool and efficient, but I want to do a whole bunch of things on strings, right? I want to know how big the string is, how long it is, and various things on the string. I want to replace characters. So I want to define an object that contains that the ASCII character list, and also provide ways to interact with that character. So it created an object, a class, an object called string, and this is what the object looks like, and this is how you interface with that, right? And that is all another big file somewhere. Okay, somewhere in the system there's another file in the same place. It probably lives in the same place where iostream lives. There's two files there, right? There's many files. These are two of the files. So again, when you say hash include string, we're able to use, say, oh, give me a compiler, give me a variable. I'm going to use a variable called name, and it has to be of type string. And it knows what string is because that hash includes string file, that line says, all right, this file string.h tells you what a string is. Okay, so those two lines basically tell the compiler this, include those two files right at the top. So in fact, what happens is that when we compile this file, we think that there's only 15 lines, but what the compiler sees is not 15 lines, because by the time this program hits the compiler, that program has been changed by those 15 lines are at the bottom of, I don't know, a few thousand lines, right? The program, the compiler actually sees is actually, maybe 5,000 lines long, of which the last 15 lines is this. The remaining lines are going to be the contents of that IOStream file and the string file. Does it make sense? So we've written only a small program, but that small program includes two other files that are really big. So the preprocessor will take care of all that. We don't have to worry, because those files are exactly the same. No matter how many programs you're going to write, those two are going to be the same. You're going to use the same objects over and over again. Everybody's going to use cout, everybody's going to use cn and string and so on and so forth. Everybody doesn't have to write the same thing. So we just include it. It's been pre-written for us. That's what those two lines mean. Okay. So now one of the things we did in the program that Tim typed first was saying using namespace standard, right? So what that means is that every time you create a variable, you create it in what is called a namespace. A namespace basically means that if, many people, right now, it's just one person writing simple programs, right? Very soon, you'll be working in a team with many people, and you'll be creating projects where, you're writing a part of the project and someone else is writing another part of the project. Now, what happens if, let's say, Shadi wants to create a variable called, I don't know, name, okay? Shadi wants to create a variable called name. And let's say Alexis also wants to create a variable called name. Oh, Alexis, I wouldn't use your name anymore, because every time I say your name, Alexa is picking up. Okay, so so let's say Musa. All right, Musa also wants to create a program. Right in the same program, but in his program also he wants to create a variable called name. And let's also assume that these two variables are in the same global scope, right? Now, when you use the word name in your program, saying my name equals Shadi or name equals Musa, so something like that, how does the compiler know which variable to use? Because Shadi also has a variable called name, and Musa also has a variable called name, and they're two different things. Yes. So rather than say put in a restriction saying, well, if you want to use our program, different people have to in the project have to communicate with each other and make sure there are no naming conflicts. Come up with some kind of a convention amongst yourself so that you all don't use the same name. So that would be one way of doing that, but it'd be really ugly and not a scalable way to do it, because you're going to have many thousands of people sometimes. Linux, for example, many people working on the same project. It's not feasible to tell each one to coordinate with all the other people to say different names. So what they did was, what we'll do is just basically create something called a namespace. So when Shadi creates a variable called name, she can say everything I do is in the namespace Shadi, right? And Musa would say everything I do, all my variables are going to be created in a namespace called Musa, which means that the compiler, as soon as it sees that, will say, oh, Shadi has a variable called name, but she is in the namespace Shadi. So I'm going to turn Shadi's variable name into something special. So Shadi's name is actually going to be seen by the compiler as Shadi_name, whereas Musa's name is, that variable name has been changed by the compiler, Musa_name. Does it make sense? So the compiler disambiguates by changing your variable name so that different people's names don't conflict with each other. Now, instead of the underscore, okay, the compiler says 2 double colons. That's the syntax that C++ has chosen. So this here is part of what is called the standard namespace. The standard namespace has been defined by the compiler, the creators, right? They created these basic things that we're going to use. They put it in a namespace called standard, STD, so that you are now free to create your own cout variable, and it won't conflict with that, because that cout is STD : cout, not your cout. Does that make sense? So when you say at the top of your program, using namespace standard, and you use the variable name, or X or Y or Z or I or JK, it means that, the compiler will say, well, is there a variable called I in my program, in my function? No. All right. Now we are operating inside of Shadi's namespace. So let me see if there is a variable called I in Shadi's namespace, right? Global scope. So it'll say, all right, now the variable I is actually std, Shadi : I, right? So it basically changes the variable names if it cannot find them and looks in different namespaces. Now this concept will become very clear in just a couple of days, okay? When we code more and more. So the things that we can do to leverage this namespace thing, or we can do one of two things, okay? One thing is every time we specify a name of a variable, like, IJK, we can explicitly qualify it ourselves. We can say, well, this variable called I, it's not, something, okay. It's not just any old I, it is the, hello? Hello?
Yeah, we can hear you. We can hear you.
Yeah, one of them fell off and it disconnected.
It just takes some time to reconnect.
Okay, yeah, I'm back. All right, so it's my variable I is not just any old I, it is Shadi : I. Likewise, my cout is not just any old cout, it is the cout that is defined in the standard namespace. Where is it defined? It's defined in the IOStream file, right? The IOStream file defines a variable called cout. Strictly speaking, it is not an IOStream file. It is in a library. The IOStream file basically tells the compiler that there is a variable called cout. It has been defined in the library, and this is what it is. That's what the header file says, basically, right? So it says that is what it is. So we can say either, when I say cout, I could say std : cout, meaning I explicitly say which cout I want to use. I want to use a cout in the standard namespace, not the cout here. Right? So that is an explicit qualification. The other way to do it is implicit and automatic qualification. We can go right to the top above main. You go to line 4 and hit enter, line 4 and hit enter. Yeah. And here you say using namespace std : Now, when you do that, space std space std semicolon and enter. Yeah, right. So once you put that line in there, it says to the compiler that if you see a variable that you don't see declared in my program, you can go and look in that namespace automatically. Now, once you do that, you can get rid of the std : in all of the variables inside, right? So you can get rid of that. Yeah, you can get rid of std : and that's basically a shorthand for the compiler saying, every time I use this variable, I'm going to be using this variable many times, but I don't want to be qualifying it with the namespace every single time. You can go and look there. That's what we're saying. You can get rid of all the std : and your program will look a lot nicer now. Yeah, get rid of that one, and also in front of in front of the cin. Get rid of the one in front of the cin also on the previous line. Right. All right. So now this will also work. If you hit the run button, you'll see that it works. Right. So you can type in something and it'll say, hello, Tim. So far, are we clear? So what we've done basically is written a simple program, right? And said, there's variables in this program that we're using a variable called name. And then, when we want to send it to the console, we want to send it to the console out object that's already been created for us. And the IOStream file tells the compiler how to use the object, right? And so we put that in there, and we say get a line from the user, right? And cin is basically what is called a stream. It's a stream. It's cout and cin. They are both what are called streams. Streams are basically pipes, okay? Pipes that interface with the external world. So cin is console input. It's a pipe that connects to the keyboard. Cout is a console output. It's a pipe that connects to the screen. Okay, and those two things have been created for us and made available. So when we say we call a function called getLine, we say here's a pipe that's connected to the keyboard, and here's a variable called name. Read from the pipe and take whatever you get from the pipe and put it in this variable. That's the function. That's what the function does. That call, the invocation, that call on line 12 basically is a statement. It says read from the keyboard cin and put it in the variable name. That's all it does, right? There's one more way of doing this. So let's get rid of that line, line 12. Get rid of the line, and we'll use the same syntax like they did in the previous line. Okay, so you say cin, and now we say right shift. Right shift is the opposite of left shift. So yeah, there you go. Right. So that's the right shift. Well, yeah, probably they call it the extraction operator, right? I'm not going to call it the extraction operator. Right shift. Right. Now you say name. Right. Semicolon. Right. Right. And then you can run it now, and you'll have exactly the same effect. Right. You can say type name. Right. And what that means is that the double greater than operator, the right shift operator is defined in the language, right? Well, not in the language, in the packages that come with the language, to say take the parameter, right? The parameter is cin, the pipe that reads from the keyboard, take stuff from there and put it in the variable name. Okay, that line basically says read from cin, put it in. And the syntax is really weird. Okay, and that is the reason why it looks kind of funky here. It's not like you're calling a function, right? Previously, those of you who may have programmed in other languages know that when you call a function, it has a certain form, right? You have the function name and then open parentheses, parameters, close parentheses, semicolon. Yeah, that's how we call a function usually. Are you familiar with that? Or shall we not talk about that? Right? Okay, so that's how you usually call what is called a function. We haven't even talked about functions yet, right? That's in week 5. But this is a really freaky syntax, but it is just a function call. Okay, that right shift and left shift are actually function calls that are written in a really, really weird way. Okay, and I don't know why. I don't know why this weird syntax. But for what it's worth, it's very easy to get used to, and it'll become part of your background knowledge. You don't even think about it; you just type unthinkingly. And these are the two weird syntaxes we need to get used to. Now, in fact, we can do something slightly better here. Let's say under string name, let's say int space int space. Let's say we want an integer variable. Let's say number of units, right? Number underscore off underscore unit, right? Enroll number underscore unit enroll, or something like that. Whatever, right? Okay. So one of the reasons why I do that, and a blank line after that, so that the declaration part and the logic part. So one of the reasons why I use these long names, like in class anyway, number of units enrolled, is that it'll save us from putting a comment in the end. So if you use some generic variable name like int I, you have to put a comment there saying, well, this is what the variable is. So this way, for instructional purposes, it's very clear what that variable is. Now what we want to do is on line 13, go to the end of line 13, hit enter. Yeah, enter. One more blank line. Now we say see out how many units are you enrolled in, right? See out, exactly the same as before. Left shift. No, by the way, one of the things I want to point out is because Tim is typing this, right? He is at an advantage because whatever we do today, it'll be super duper easy for him because he's typing it. What every one of us should do is essentially do exactly what Tim is doing on our own screen, on our own terminals, at least one, preferably during the lecture. Even during the lecture, you probably have a laptop or another screen where you're doing exactly the same thing. And if you're doing it and it doesn't work, you got to chime in immediately and say, hey, I tried it, didn't work. Fantastic, okay? If you looked at what Tim is typing and say, well, I can understand everything that he's doing, that's fine. I'll read it later on and I'll try and understand it. It doesn't work, okay? You'll have to spend 5 times as much effort as Tim to understand what. So please do type everything as we're typing on your own screen and make sure you're also able to do exactly the same thing. Hey, Shadi, you have your hand up?
Yes, I had a syntax question. I know that you mentioned that these two little opening brackets, like these two little left side signs,
Yeah. Left shift, and right shift.
left shift and right shift signs. You did mention that they're like some form of data representation that they move to things to the right sometimes.
Yeah.
But
Yeah, you want to try that? You want to try that? Because it's very quick. We can do that.
sure.
All right, cool.
I was just trying to understand what is it? Why do we do that? And when? Because
Okay.
on line, what line is it? On line 18, we have 3 sets of those. When do we use those brackets?
Sure. Okay. All right. Okay. Now, those left shift and right shift in this context with C out and C in, they are not shifting. Okay. Maybe that's why they're using insertion and extraction operators, the terminology there, because in this context, they're not shifting, right? They're just the same operator being used for something else. Those things are basically operators like plus and minus. Okay, left shift, they're just operators, regular operators like plus and minus. C++ gives us the power to redefine anything you want. Okay, so you can take a plus, minus, times, divide, and you can redefine the plus and say, plus, I don't want plus to add 2 numbers. When I say plus, I want to take a string and concatenate the string with something else, right? So you can redefine plus to do something else. In fact, you can redefine plus to do anything you want. You can say, when I invoke the plus operator, I want to format my hard drive. Okay, so you can do anything you want. C++ gives you the power to change anything. So like that, the left shift operator, essentially, originally in C++, what the compiler does is to basically do a shift of the bit pattern, right? If you have a bit pattern, the left shift operator is going to take the bit pattern and shift it left, right? And the right shift is going to, and I'll show you how to do that. We'll see it in action. I'll not show you how to do that. We'll see it in action. But then when people created C out and C in, for some reason, which I've forgotten or I don't know, right? They said, what is a good way to send stuff to the console? I need an operator, right? And then I can tie a function to that operator. Every time that operator is there, I want to say, this is how the operator behaves. So can I use a plus for that? No. You know what? C++ has a less than sign, left shift and right shift operators. Let me use that. So that is why they took the left shift and right shift operators and redefined them in this context to do something completely different from shifting. Okay, so that is, again, a source of confusion for beginning students to say, well, this is an operator that does bitwise operation. And in this context, it's not doing bitwise. It's actually shifting things back and forth from the screen and the user, right? So 2 different things completely. And it could throw people off. And thank you, Shadi, for bringing that up. So we're going to do something that, Shadi brought up. So after this, okay, after this. So do the same thing here. C in, double greater than, yeah. I said double greater than, not right shift now, right? Double greater than, number of units. And then hello name. And then on line 18, hit enter. Yeah, and now you say C out. Yeah, double less than. You are enrolled in. And then close quote. And then you want more left shift. Okay, so yeah, I think that's one of the reasons. I think that is probably the reason why they use the operator, because when you use the operator, you can just chain many things. You can send something to the pipe, and you can send more things to the pipe on the same line. So you can say multiple left shifts on the same line. So you can say multiple things. I'm sending multiple things to the console on the same line. So here you're saying, I want to send the string you are enrolled in. And then after that, I want to send the number of units enrolled. And then at the end, a new line. Now, one other way in which you can send a new line is to use the word, you can use a variable, a special variable called ENDL, okay? ENDL, that's end of line. So instead of that thing there, you can say ENDL. No, you can't put it in quotes because it's actually a variable, okay? It's so you say ENDL. Oh, and you want an exclamation mark, okay? All right, so he is surprised at the number of units. We're going to be surprised at the number of units. ENDL. No, it's still ENDL, ENDL, ENDL. Okay, so now if you run this it'll ask you 2 questions, okay, and it'll shift 2 lines to the console, right? First, it'll ask for the name, and then it'll ask for how many units. 1 unit, okay. You are, oh, I see, you didn't put the word one, you put the word units before NL, right? Put before, unit, okay. Right. Is everybody comfortable with this so far? Okay, this is your very first program, and it's interacting with a user. Okay, it got the name, it got the number of units. It's 2 different types. For the first one we got was a string, and the second one we got was an integer. And then the operator knows, and this is a special thing, right, of the operator, and it's the power of C++ is that there's a special thing called overloading, okay? Overloading and polymorphism, these fancy words that you learn later on. What that means is that this operator is tied to a function that knows how to behave differently depending on the type of the parameter it gets. So you can define one function that says, if I'm given a string, I'll do this. If I'm given an integer, I'm going to do something else. But the user doesn't need to know that, call me differently. You can just call me by name, right? So this is I can say, hey, Mike, right? Different tasks, right? Different tasks, but the same thing. The same thing can do different things depending on what it's given. So if I'm given an integer, I'm going to do one thing. If I'm given a string, I'm going to do something else. That operator knows how to do that. And that is why we can unthinkingly shoot different things at it. We can give it a string, a constant string like you are enrolled in. And then you can also give it an integer. You can also give it an object like endl. And the operator knows with the pipe, it knows exactly what to do in each of those cases. That's why it works. Now, if this is clear, we'll do that one more thing that Shadi wanted, and then we can spend more time, dissecting this program and exploring it in more detail. Okay. So on the next line, let's say we'll create one more variable here. Okay. Blank line there. Now we're going to put a comment there. Okay. Put a comment there and here, so type in here, we will create a numeric variable. Comma, multiply it by a power of 2. Actually, multiply it by 2. Let's say multiply it by 2. Multiply it by 2, and then print the value. Okay. And in fact, after multiply by 2 by shifting, by left shifting. So by left shifting. Yeah. Okay. All right. Now, actually hit enter after shifting. Hit enter after shifting. Right now, comment that. Okay. Yeah, I do that because visually, I think that more than 80 columns. And even though we have big screens these days, most programmers that I've worked with, even though they have big screens, will stop at 80 columns. Okay. And it's actually much easier on the eye to have. Okay. Now, on the next line after that, let's create the variable. Okay, so let's say int, let's say int j, right? And then we'll give it a value right here. So space equals space, right? So put a space around the operators. Space equals space, and come up with a number. Someone come up with some number under 100, hopefully. Okay, come with a number under 100. No, it doesn't. It shouldn't be within quotes, right? This is an integer variable. So someone tell Tim a number to type in there, right? Doesn't have to. I can say it's not a big 22. Deal. 22. Type 22. Right? Semicolon. Right? Now on the next line, you say j equals. J equals. Space equals space. J space. Well, yeah, I don't want to say left shift. Yeah, in this case it is left shift. Okay, left shift 1. Semicolon. Okay, now and then a few spaces, and then start an inline comment right on the same line, on line 24. on line 24 itself. On line 24 itself, yeah. Space before the comment would be nice. Okay, now this statement multiplies j by 2 by shifting all the bits to the left by 1 position. Oh, shifting also works. All right. All right. So okay. So now you can say C out on the next line. You can say the value on the next line. You can say C out. No, left shift. When you send things to the console, it's the left shift. Read from the console, it's right shift. Right? Right. So and within quotes, you can say the value of J is yes, and then yeah, left shift J and then L. Now we'll do one more thing here. Triple click on the line. Triple click, 3 clicks. Now Control C to copy it. You've done Control C. Right. Now go to line 23, end of line 23, and the end of line 23. Enter. One more enter. And then paste it. Control V. Yeah, and fix up the indentation. All right. Now, what we've done there is essentially defined a variable called J, assigned it the value 22, printed out saying the value of J is 22. It's going to, and that line will print out the value of J is 22. Yes or no? Yes, because J is 22, and we're saying print out the value of J is going to say J is 22. Yes. Now, this is one thing that is going to be very useful for us is before running any program, especially simple programs, we should run it in our head to see, you know, what is the output going to be? Don't run it. Never run the program before running it in your head. I mean, who knows? That program might, you know, destroy the whole world, right? So when we write a program, run it in our head first to make sure in our head we can simulate it, and then run it, and then you'll either be surprised or happy. You'll be happy if it works as you expected, and you'll be surprised if it doesn't work. And then hey, it didn't work. That's fantastic. Now I got a juicy bug to go and look in, right? So now if you run it, you'll see. Now, before you run it, what is it going to say, right? What will it say on line 29? What is the value going to be? Someone take a guess.
2.
Hmm?
11.
44.
44. Okay. Now, Shadi was going in the right direction, except she interpreted the double less than as a right shift, not a left shift, right? If you shift everything to the right, everything will be divided by 2, right? So let's do that too. Right? Now, copy triple click, copy lines 20, copy lines 27 to 29, 27 to 29. Copy those lines, yeah, and then paste them again below. Paste them one more time below, right? Yeah, paste it there. Now, instead of do what Shadi wanted, right? So change that to a right shift instead of a left shift. Now, instead of shifting, so what we did here was we took the number, left shifted by 1, which is basically going to turn into 44. Who said 44? Jaden? Did you say 44? Or who said 44? Someone said 40. Oh, Mike. Yeah, all right. So Michael. So we took the 22 multiplied by 2, turned it to 44. It's going to print 44. Now we're going to say, well, we took the now J is 44. We're going to take the 44 and right shift it by 1. And right shifting is going to be dividing by 2. So it goes back to 22, right? But instead of right shifting by 1, let's right shift by 2. So instead of saying, you know, right shift by, you know, there, can turn that 1 into 2. Now what it's going to do is take that number and right shift not by 1, so it doesn't bring it back to 22. It went to 44. It doesn't bring it back to 22, but it's going to take it 2 steps. So take it to 22 and then take it to 11, right? So now change the comment to say this statement multiplies and divides J by 4, and by shifting all the bits to the right by 2 positions. And also there's fix the spelling of multiplies on line 27. It's IES, and change the Y into IE. Change the Y into IE, right? So all right, cool. Now if you run this, you'll actually see it print the value 22 first. Was it 22? Yeah, print it 22, and then the second thing it's going to print is, what is it? 44, like Mike said. And the third thing it's going to print will be what is it? 11, like Shadi said. Does that make sense? Now, internally, what happened was 22. What is 22 in binary? Well, 22 in binary is 16 plus not 4. 16. Oh, is it 16 plus? No, 16 plus 8 is 24. So 16 plus 4 plus 2. 16 plus 4 plus 2. Yes, that's 22. Okay. So in binary, 22 is nothing but 16 is 1, 0. 16 plus 4 plus 2. 16 plus 4 plus 2. Yeah. All right. So let's start from it. All right. Put a comment there. Now put a comment there. On line 34. On line 34. Oh, actually not on line. I'm sorry. I'm sorry. On line 23. On line 23. On line 23. Let's say put a comment. In binary, this would be. In binary, this would be. Is it 10110? Yeah. Is that correct? Yeah, I think it's correct, isn't it? 110. All right. Now do the same thing for 44, and now in binary that would be, yeah. In binary, say in binary, 11 would be, yeah. This would be 11, is it? Is it 11? Yeah. So 11 would be 8 plus 3. That's 8 plus 2 plus 1. That would be 111, is it? No, 1011. 1011. Yeah, 8 plus 2 plus 1, 11. Yes. So that's all right. And then let's do the same thing for 44. 44 is 32 plus 12. So that's going to be 32 plus 8 plus 4. 32 plus 8 plus 4. Yeah. So it'd be 1 and then 0, 1, 0, 1, 1, 0, 1, 0, 1, 1, 0. Yeah. Okay. Now look at all the bit patterns, right? No, I know that something is wrong here. We got the same thing as 22. I think it's 1, 0, 0, 1, 1, 0, isn't it? Is that right? Yeah, that is 32, isn't it? No. Something is funky here. No, 44. What is 44? 32 plus.
Get rid of the 2 and then add the 8.
Oh yeah. Okay. So 32 plus 8. That's yeah. That one. 101. Yeah. If we start from this side, we need what is the number? 44. 44. So 0. I keep forgetting. What are the numbers we need to add? 32 plus 8 plus 4. So 0, 0, 1. That's 4. So 0, 0, 1, 1. And then no 8, no 16, and 132. Okay. So 0, 0, 1, 1, 0, 0, 1. Is that right? 0, 0, 1, 1, 0, 0, 1. No, you got too many there. Is that 32? Is that 44? No. Oh, I see. You flipped it over. It starts from this side. I was reading out the numbers from this side. I'm sorry, Tim. Right? When I was speaking out the numbers, I was speaking out numbers from this side. So it needs to be 0, 0, 1, 1. Yeah. 0, 0, 1, 1. Yeah, I think that's 44, isn't it? Is that 44? 32 plus 8 plus 1. Yeah, that's 44, isn't it?
Since we already have the 22, we're just 50 left one, so we can write the 22 and
Yeah,
add a 0.
yeah. Thank you, Mike. Okay, so Mike basically told us, instead of doing this complicated binary arithmetic in your head, you just take 22 and left shift everything. You get the answer. Yeah, that's what Mike was saying. So
1, not Mike.
Sorry.
Oh, 1 was talking.
Oh, 1. Oh, 1. Yeah. Where's Mike gone?
I'm
Oh,
still
yeah,
here.
you're up there, right up there. You're on my window. You're just really close to each other. Okay, 1. Yeah, thank you, 1. All right. So you see that the bit patterns are basically just left shifted and right shifted by 1 and 2. You get exactly the same value. And then multiplication has got the same effect as bit shifting pattern. All right, now if you run it now, you'll see, oh, you've actually run it. Okay, so was this useful? Okay, we covered the operators, shifting of bits, tying it in with our data representation that we did before. Okay, and also how to input and output to the screen and read from the keyboard. Yeah, so all of that, essentially, this little fragment encapsulates. Anything else we can do today? What time is it, by the way? Wow, it's time. Well, we got a little bit of time, right? We got like 5 minutes left. I didn't even mean to be talking this entire time. I wanted to give you guys at least a half an hour today to play around on your own. What I'm watching, or not in your face. But we'll do that from next class onwards. Okay, from next class onwards, we'll try and wrap up my the part where I'm speaking and coding with you guys. We'll try and restrict that to, I don't know, the first hour max. Okay, in the second hour, I think you guys will like it. Okay, in the previous classes that I taught, that part was really the favorite of many students, where you get to code in a shared screen, one of you and then all of you sharing screen and switching screens and saying, okay, now let me share, and so on and so forth. And then coding things not working, and everybody's trying to figure out not working, and then okay, let's call on and then ask them what's going on. And that was a greatly enjoyed part of the lecture. Okay, and I liked it too, because every time I come back, I see some really cool stuff that you guys have worked on. Okay, and then say, all right, now that's a really nice idea. I'm going to take that on to my next quarter and get my next quarter students to work on your idea. So that really was a very nice part. Let's try and do more of that from next class onwards. But I want to make sure that this class was useful to you, and you, even though the VS Code exercise was, pretty painful and we didn't actually manage to make major headway. But I'm hoping that one of you, hopefully Shadi or Nate or someone, will find out how to install VS Code and have the very first program going with the include path configured and all, and hopefully post instructions. Better yet, post a short video, even if it's like 10 minutes, that's fine, right? Basically uninstall VS Code on your system, get it to install and do your very first Hello World program in it, and capture that whole thing in like a 10-minute video. And then when you've got it going, then do it again. Uninstall everything, and do it again. But the second time, record it. I say record it the second time, not the first time. Or you can record it the first time too, because in the first time you probably have issues, some problems installing it and getting it to run. And I thought, well, we shouldn't have these problems. Now I'm thinking, no, we should actually have these problems in the video, because many students will be running into these problems in the process of installing the compiler. So it'll be good if you actually capture the entire process, even if it's a half hour of, I'm going to try and install VS Code. I have absolutely no experience with VS Code before. And in fact, I'm even learning C++. I'm going to install VS Code and see if I can get it to go. And you can capture the entire screen, going to Google and typing in how to set the include path and so on, and configuring it, and say, well, and that video will be a really nice capsule of information, which shows a brand new student in CS2A, anywhere in the world, really, not even CS2A, anywhere in the world who wants to learn C++ and computer science and VS Code. They will have this video where they can say, oh, that's another person just like me, right? Didn't know anything, and they're starting to do it. Let me follow them, and they're running into these problems, and that's how they're fixing these problems. And finally, they got it to work, and that's what I got to do too, right? And that will be so encouraging and also reassuring to many beginners. Okay, and if one of you who's got a bit more experience with VS Code can do that, that would be absolutely fantastic. And what we'll do is, again, like that, Virginia's video, we'll take that video, and I'll give you this. I think I got to set you up as a manager of the channel, and you can upload it to our channel, and it'll be up there for future quarters students. Like Tim did, 5 quarters from now, they'll say, oh, I looked at the video and it's not working. Okay, that's fine. Okay, but it actually helps like for the many students. So that'll be really nice, right? And if nobody can do it, let me know, right? I'll see if I can do the video and post it. Ideally, it should be videos produced by students, okay? I can tell you, students watch videos produced by other students much more than they watch videos produced by professors. So if you produce a video and put it there and share it on Reddit and saying, hey, I made a video, go and take a look at it, you'll see immediately that lots of students go and take a look at it, okay? And they may even comment on it and say, thank you, thank you, thank you, and so on, okay? It's going to be useful. And it'll be worth participation points too, right? So please do it. And it doesn't have to be just one video, right? Even if all of you go and produce videos like that and put it there, great, okay? You know, it's going to be a fantastic example for future students. All right, so then thank you all. Was this lecture useful? Was class useful? Yeah, thank you. I hope it was. I hope it was, and I hope you got something useful out of it. And I'll see you on Thursday. Well, on Thursday, what are we going to do? Yeah, we'll do branching. We'll do. No, branching is supposed to be next week. All right. Well, I'll think of some interesting problems to code on Thursday. Okay. Which does not involve branching and looping, but still interesting enough to do with the basic things we have, right? We only have 2 tools and we still have to do interesting things with these 2 tools. If you can think of interesting things to do with just what we know so far, variables and C out and C in, you know, share it and we'll do that on Thursday. Otherwise, I'll certainly think of some interesting things to do. All right. And next week, we'll do branching and looping. But before we do that, you should be really, really solid on input and output and these basic constructs, because we'll be using that unthinkingly from next week, right? And then the week after that, we'll be using branching and looping unthinkingly, right? We're going to say, hey, we want to do this. Let's loop again, right? Let's loop again. Oh, you want to make these decisions. Let's do this. So we'll every week, what we learn, the following week, we'll use it unthinkingly, which means it's not just enough to be familiar with what we're learning. We also need to have lots of practice so that it's internalized, so that the week after, you're not thinking consciously about, oh, this is how I do it. This is how I do it. It just flows, right? Because when you're talking in English, you're not thinking about how to frame each sentence. You're just talking, right? Like that. So these are the basic words of C++, just like the basic words in the grammar of English, the basic grammar of C++. Syntax is grammar, okay? So when we are comfortable with the grammar, we can just start speaking in C++. And when we start speaking in C++, you can do the equivalent of what you do when you speak in English, which is basically start communicating interesting and creative things to other people, right? You want to be able to communicate interesting and creative things because you're all so chock full of creative ideas, creative thoughts, right? And many of these thoughts you can express in English and natural language, but there are some thoughts, some ideas that you have that you cannot express in English. You need an environment like a programming language in order to bring your mental castle into reality, right? So this will equip you with that. And when you are familiar with the language, you'll be able to express those thoughts too. And other people on Stack Overflow and all these other people on the internet, they'll be able to look at that thought that you expressed in C++ and say, wow, that is beautiful, right? I'm going to take that fragment and incorporate that into my code, okay? And that's the place to be. So we'll get that very soon, okay? By week 6, you'll be creating code, right? If you stick with this, by week 6, you'll be creating code that you'll already be starting to get proud of, okay? And by the end of the quarter, I tell you, right? If you manage to make it, I know I mentioned this in the syllabus saying you only have to get to class 6 to pass this course. Yes, that is true, right? If you get to class 6, you'll pass this course, but please don't stop there, okay? It's not enough to just pass this course, because passing this course only tells you, well, this is C++ and this is how, you know, this is a C++ programmer, that's what they do, right? So you can relate to them, but that's not what you want. You want to be creators because you're a creative person. You want to be creators. So you don't want to understand and get to relate to other creative people. You want to be creative yourself. So if you want to be creative yourself, you got to go all the way. And quest number 9, not quest 8, okay? Quest 9 is different. That's what I told my 2B and 2C students. Quest 9 takes more time than all of the quests put together, right? You can solve, when you finish CS2A and go on to CS2B, you will be in a position where you can solve all 8 quests, the first 8 quests in one sitting, okay? You sit in front of the computer, one day in 5 hours, you can knock off quest 1 to 8 like that. You should be able to do that, and you will be able to do that. Quest 9, however, no matter, it will not take you, well, it'll take you at least a few hours to do, right? It's not going to be like one sitting. There'll be bugs. You got to stop there and go for a walk and come back and talk to other people and think about it, right? It'll take you a longer time, and that's really, really important. So you finish quest 9, right? Of quest, this class, right? So persevere and get to that, and you'll be like super duper grateful to yourself for having done that. And in 2B, hopefully I'll see all of you in 2B. And there, you know, in our classes, when we meet in CS2B, you will be surprised. You will be talking about stuff in C++. We'll be talking like in a different language. And then you won't be thinking, oh, let me try and make sense of it. You'll actually be thinking about the problem and the logic, right? Even though we're talking in C++, that'll be invisible to you. And that is a place to be, and we'll totally enjoy that. Okay. So thank you all so much for your patience and putting up with my constant blabbering today. Hopefully we'll not have that from next class on, and you will be talking more of the time than me. Okay. And you'll get more time, more of a chance to code. And thank you, Tim, for taking over the screen and being so kind today. And hopefully more of you will participate like Tim, right? And code and more than one person coding in the same class too, right? Sharing screens, switching screens, and so on. That's all part of the fun, and we'll have a great time. All right. Then thank you all.
Wait,
Any other questions? Yeah.
Yeah, quick question. So if we wanted to, sorry, Jaden, if we wanted to volunteer to share screen and code, where do we do that and when?
Oh, any class, anytime, even in the middle of my spiel, right? If you say, hey, Anand, just stop talking. I want to share my screen. Okay. All you have to do is I'll stop and you hit the share screen button and you can take the screen from there.
Okay,
The only suggestion I have is that before you share your screen, please make sure that you're only sharing your Chrome window, and that Chrome window needs to be incognito mode. Okay. Because we don't want accidental exposure of passwords or social security numbers. And then I have to go and edit the whole video and I don't have time for that. Yeah.
Okay. Sounds
good. Thank you.
Thank you.
Thank you. Bye.
Thank you. Bye-bye.
See you
Quick
after
question.
tomorrow. Yeah. Go ahead.
I just want to make sure of something. So when we do a quest, like quest 2, that's comprised of mainly mini quests, we submit every single file to get.
Yes.
Okay.
Yeah. I think in CS2A, at least until quest number 6, there's only one file you have to submit most of the time, right? When you get to quest number 6, or maybe even 4, yeah, maybe 4, you have to submit 2 files, but all of your mini quests will have to be in that one file. Yeah.
Thank you.
No worries. All right. I'll see you on the day after tomorrow. Bye.